Okay, so this talk is about writing maintainable software in Clojure. Its original title was Clojure is not a silver bullet, but that was perceived as somewhat negative. And what I mean by that is that even though Clojure is the best language I ever worked in, it hasn't stopped me nor others from writing applications that are both messy and unmaintainable. And as many of you have experienced, it's fully possible to write bad, unmaintainable code in any language, Clojure included. And giving a talk on how to write maintainable software is a somewhat scary task. There's good programmers in the room, I might have missed the point, right? But I'll limit myself in this talk to highlighting some of the things that I find specific to, if not Clojure, then at least languages that share some of the characteristics with Clojure. So I won't be talking much about pure and side-effecting functions, even though they're an integral part of writing maintainable Clojure. And in fact, this quote here is a paraphrasing of a colleague of mine from way back when I was learning Simula at the University of Oslo. I said that Simula was great because it was object-oriented. It was the best. And he retorted with, I can write object-oriented code in any language, which is true. But just as with object-oriented code, it's the same for messy code. Some languages are better suited for it than others. So this is a slide that shouldn't have been here, but I can take it since it's there. My problem with Clojure, because a lot of people have problems with Clojure, and my problem with Clojure is not the error message. It is not that Cognitect never tells us what's coming next and when it's coming. The problem with me for Clojure is that there's not enough Clojure jobs. I work in Oslo, and there's maybe 1 or 2 Clojure positionings opening a year. And so I think it's on us as a community to go out and make sure that there are Clojure jobs available to us, which means we have to go out to the other communities and communicate about why we like Clojure and what's great about it. And also, not just pointing out that we have parentheses on the right side of the function, but actually illuminating them on how Clojure helps us solve the problems that they have, or even eliminate the problems that they have. So, some background for this talk. I worked in the web for the most of my career. I work in the SaaS business, basically taking stuff from the internet, putting it into a database, and then displaying it again. Who else does that? Yeah. I have good monitoring, so correctness is not super important, although important. I can catch bugs when they happen in production. I have changing requirements. And the stuff I need to do is never finished. It's not like I just implemented a spec and I'm done. As such, I work on evolving systems that live for a long time, and whose main requirement is that they must be adaptable to change. I've done this in many places, but today I work at Ardoqs. It's a Norwegian startup in the enterprise architecture space. I came for the language, which is Clojure, and I stayed for the culture. The interesting bit for this conference is that the backend is a 7-year-old Clojure project, now being maintained and developed by 5 different devs. The API server, on which I spend most of my time, has some 73,000 lines of code, of which 27,000 of them are tests. So what we do in the simplest term is that we collect nodes and edges, and we let you assign attributes to the nodes and edges, and we visualize that for you. So this is a visualization of some namespaces in the Ardoqs codebase. But you can, instead of having just one tool that lets you do this namespace visualization, you can assign other attributes to your codebase as well. So this is another view of the same data. And what it shows you is the x-axis is some sort of complexity, some measurement of complexity, like cyclomatic complexity. The y-axis is the number of forms, so how big is the namespace? And the size of the bubbles indicate how many other namespaces are dependent on this one namespace. So this lets you do some analysis on the code on a big code base, and it lets you visualize the results. So what we see here is that errors happening in Ardoq utils is not a good thing because there's a lot of downstream dependencies on this. Whereas this little red dot, that's the highest red dot, it is a huge namespace. It's somewhat complicated, but it doesn't have a lot of dependencies. So maybe it's not that important. The other thing we can do is we can take this code base and we can link it up to other things like capabilities of the applications. So we can see that this namespace here underpins this super important capability of the application, and then we can see that here we need to put some more effort into making the code clean and pristine. So this is today's agenda. I'll start with a little bit more of motivation, and then I'll look at some of the tools you can use to write more maintainable Clojure, and then of course we'll end up with a summary. So let's start with the motivation. Michael Feathers wrote this book in 2004, where he defined legacy code as code for which there are no tests. There are many ways to define legacy code, but for this talk, I'd like to define it as code that is proven to provide value over a longer period of time. Code that is not done, code that is under continuous development, code that's living. So the question goes from how do we work effectively with legacy code to how do we effectively write legacy code? Now, the gut reaction for many developers when faced with what we normally call legacy code is to reach out for the bluntest tool in the toolbox, the rewrite, right? This code sucks, we'll just rewrite it. But as other people smarter than me have written before me, there are things you should not do. I won't go into the details of why a big bang rewrite is not a good idea, but basically do not do that. And I think for maintaining code, you shouldn't think about this as construction, but it's more like gardening. It's work that goes on forever and ever. You're never done. Things have to be changed and cultivated. And what I hope that we end up with when we do this is that we get code that is simpler and easier to understand. And this is at least the problem for me. I cannot understand complex code, so it has to be simple. And especially when you look at this, if you write complex code that's at the level of where you're at, you will not be able to debug it later. And when we talk about code, let's talk about code size, because there's this number called the Norris number, which describes how many lines of code a novice programmer can hold in his head before it becomes a mess. So the novice programmer can hold about 2,000 lines of code in his head. So you can have that in one file. So if your program is small, code organization doesn't really matter that much. But as your code grows, you have to start caring about how you decompose your application. And I think it's interesting to look at how your code grows, like for each order of magnitude. Once it sort of approaches another order of magnitude, you have to take care and look, is this going the way I want it to go? Is it implemented in the language that I want it to be implemented in? How can I change this now? And of course, programs are written for people to read as much as they are written for machines to execute. It is much more important to write readable code than it is to write code that suits the machine. Whenever I'm faced with a choice between performance and readability, I don't care much about performance before it's really proven to be a problem. And in this talk, I'll be going through some code examples. Some of them are written by my boss. Some of them are written by my colleagues. And it's important to understand when you look at old code that this code was written with the best intentions. And I think that it's important when we look at legacy code that we understand that. And regardless of what we discover, that we truly understand and believe that everyone did their best job given what they knew at the time. Ardoqs was started in 2013 by developers who wanted to develop in Clojure, so it's just natural that the code that stems from that period is not as pristine and as good as the code hopefully we write today. So, with that said, let's go on to the tools. So, Sussman and Abelson, they wrote this paper back in '87 about stratified design. And I think that most of us has seen code like this, right? It's quite simple. It does its job. But as vigilant developers, we see the duplication here, right? So what do? If you were writing in Java or if you use Cider, you can use extract function, right? You solved it. But in fact, you haven't. Because top-down structured design produces systems that are organized as trees. If you look at this code, there is no way for us to calculate a foo or a bar without also extracting it, or also inserting it into the database. So the bigger problem here is not like the duplication, but it is that it's as coupled as it used to be previously. So what you want to do is, of course, you want to extract the functions foo and bar so that you can do this without persisting to the database. But then, of course, your colleague that just wrote this code, that didn't extract them, he's going to say that, oh, I'm never, ever going to have to calculate a foo without persisting it to the database. But that's when Abelson and Sussman steps in and says that if a system is to be robust, it must have more generality than what is needed for the particular application. And this is what we saw in the previous talk as well. You want your changes to be additive. You don't want to change stuff that is already working. So when you want to do foo in another context, it's really nice to have this foo function available to you without persisting to the database. Speaking of generality, there is, however, a cost to generality. And I want to talk about the differences between being general and specific. So if we look at Clojure, and we look at how we move up and down in the layers of our applications, we also move along this axis of specificness and generality. The further down we go in our layers, the more generic our functions become. And what's interesting about this in terms of Clojure specifically is that we tend to present our domain objects as maps. So we're free to use generic functions on maps in any layer of the application. But I strongly suggest that we take care to use the appropriate level of specificness given the layer. So we have reset password. This is something that we're doing in the layer of the user, in the layer of our business. Whereas here, we're operating on a map, so we can use a soch. And down here, we could operate on a sequence, and we can use the things that are appropriate to that layer. But it wouldn't make sense to sort of have const user password up at the user domain level, because that is too general. So here's a piece of code from our code base, and this is update user. It is very general, but it's still at the very top. It's what serves the update user request. And it's a very generic function. It seems like it's update user. But as you can see from this code, you're only allowed to update accepted terms, names, or settings. And you could start asking yourself, does it really make sense to say that you can update accepted terms? But that's basically beside the point. You've accepted them or you have not. And there's also a nice surprise for you here if you try to update the user with any any other than these keys, right? Because the case statement blows. So instead of having this one generic update user endpoint, maybe we should have made us 3 user endpoints. One to rename the user, one to update the settings, and one to accept the terms. And that would let your API speak the language of your domain, and also it would be clearer about what you're allowed to do with your user and not. So the next thing I want to talk about is the what versus the where. So we have this thing called the law of Demeter, and it basically says don't bind together what you want to do with where it resides. This goes for operating on deeply nested heterogeneous maps, as well as writing functions which operates within those collections. So you might know this from work being done in other languages, and when I was learning Simula at the university, this was expressed as don't use multiple dots. But we're not coding Java, so what's the equivalent in Clojure? So let's have a look at this function from our code base again. There's a lot going on here, but basically what this function does is that it says if you have the privileges that are create, update, and delete, replace those with edit. It makes it a little bit simpler for the front end to handle the permission logic. But the main problem here is not that the code is convoluted, it's that it knows way too much about the structure of how we represent permissions. And as you can see, what we want to do is tightly coupled with where it's located. So let's try to refactor this. So what we can do is that we can take these two things apart, and now we have a nice little function, maybe replaced with edit, that is decoupled from where those privileges are stored, right? So now this one can be used in unit tests. It can work on the exact problem that it's trying to solve without having been passed a total permission object. Then we have named versus anonymous. One of the things that I really like about Clojure, coming from Java and other languages, is that there's a lot of things that do not have to be named. We have threading macros, we have anonymous functions, and we tend to store our entities as maps. So there's a lot of things that we do not have to give names. And a lot of those names are what I'd like to call intermediary names that don't really make sense. As you thread through a pipeline, there is no need to name each and every one of those sub-artifacts. But this freedom to align names also come at a price. Since these anonymous things, they float around in our code base. Reading the code base becomes hard because we don't express stuff in the language of our domain. And we have to parse the anonymous functions to figure out what are we actually doing inside this map or this reduce instead of using a name for it. And you might have to write comments too. So it seems that the more we rely on anonymous functions, the more we are in danger of duplicating important logic in our code base, since it gets harder to grasp the similarities when they're not named. But as we all know, there's only 2 hard problems in computer science, cache invalidation and naming things. And it is hard to name stuff, but I would say that a succinct language like Clojure, where you don't have to name stuff, it leads to a lot of duplication. I've seen this more in old school JavaScript, where you have a bunch of callback things that are just inline, 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 inline functions, and that's actually where the meat of the application lies. So, naming things. Name things for what they do, not how they do it. And a good name describes the intent and not the implementation. And it makes sense in the domain for where it is used. So let's have a look at a couple of examples to that. I found this floating around on a pull request, and it's like, what is 2? I had no idea, and I generally do not read comments because comments do not run. So I had no idea about this implicit reference type. And I think that if you were to grep around in the front-end code base and the back-end code base, you'd see this magic number floating around. So basically, this could be put into a constant. And good, now we have this thing that we can talk about, and it's easier to understand our domain. Names give us another thing too. It gives us another level of indirection. It gives us wiggle room. It gives you the possibility to change how things are done in the future. And that's important for programs that evolve over time. Unfortunately, we do not use Datomic as our source of truth. We use MongoDB. But we do not want to let the object IDs of MongoDB infest our data or our application code. So basically, we take the ID of a document and we coerce it into a string. And this is like, I don't know, 10-ish characters to type. So why would you want to bother creating a function for this? Which we have. We created this one. It gives us a couple of things. First of all, it lets us be precise about the inputs and the outputs. You give me a map, I'll maybe give you an ID. It also gives us something that I didn't think about is, what's the answer to this function call if doc is nil? Anyone? Empty string, right? And we don't want that. We want nil. So we get to fix this in one place instead of going all over the code base and fix it in every place that we do this. And it also gives us a really nice idiom. We see this and we understand, yes, we're now taking the ID of this object. And that's the thing. You don't build software with string double or HTTP client. You have phone numbers, you have price, and you have remote warehouses. You have the power to create your own language, use that power. So to sum up naming things, name things that are part of your domain. When you foresee a need to change the implementation later, it's the level of, or another level of indirection. And if you're in doubt if you should name it or not, name it. Then this is not a political talk, but I still want to talk about liberal versus conservative. For APIs, we have this thing that you should be conservative in what you send, but liberal in what you accept. I think that this is good advice for open APIs, but I think it's terrible advice for your internal functions. Internal functions should be conservative and precise, not only in what they send, but also in what they accept. Because adding flexibility makes code more complex or complicated, and sometimes that will also make it more complex. So let's have a look at what this could look like in the Ardoqs code base. This function is super flexible, written to handle almost anything you can throw at it, at the cost of being totally impossible to read. It's too nice in several ways. First, if you don't have a user, we'll get you a user. Secondly, it accepts an org in several ways, either as a map containing a label or a string that is the label. Thirdly, it's way too insecure, and that confuses us. It seems like there are situations when an org might not have a label. You may start to wonder, is that a legal state of the app, or was that just a problem that someone had because they had a bug at some point? What would happen if we have an org without a label? And why should it be ignored silently? In a typed language, if you wrote specs for this, you would see that the spec would be way too permissive. So let's have a look at a better way of writing this. Now it's quite clear, right? We have an org, it has a label, and we can see what this function does. So when you write functions, please be conservative, because flexibility comes at a price. And also look for invariants at the level of your layer. So in our application, an org always has a label. If the label's not there, we should blow up. Which brings us to the summary. Basically, be specific according to the layer. Decouple the what from the where. Name things which are important to the layer. If your code base reads like map, filter, reduce, and that's all the names that you have in your code base, you're probably implementing Clojure core maybe, but you're not implementing a library, or sorry, an application that serves a business domain, because very few businesses are in the business of mapping, filter, and reducing. And be conservative inside your application. Go looking for invariants and be strict on what you accept so that you can discover errors early. That's much better than down the way. This has been writing maintainable software in Clojure. Thank you. And if you want to work in Oslo, we're hiring. Yeah, sure.
Okay, thank you very much, Erik. Erik is happy to take a question or two if you have any. Yeah, Ben, go for it.
You said that you should use the level or specificity for the function at hand. Do you have any? Can you share some heuristics to know what layer you are currently working on in a certain function?
Yeah. Basically, we have, like, the way our app is structured is around, you have the API layer where the layer there is, marshalling, unmarshalling of HTTP requests and doing validation of that. Then it's great to talk in the language of HTTP and validation, right? Then you go down to the service layer where you handle the things that the business actually care about. That's where you should have your reset password or accept conditions, or accept terms or whatever. And then below that, you have the database layer where what do you do there? You update things, you find things, and basically, even though you're working on the same map all the way through that, the map has different characteristics. Yeah. Does that answer your question? Absolutely. Thank you.
Okay, maybe one more question if we have one more. Yeah, okay, here we go.
Ex-colleague.
Next Ben. Next Ben.
So I was wondering if you had any thoughts about protocols. So when you're talking about different layers, whether that's something that there are pros or cons, and whether it's too specific, or perhaps you could elaborate.
Yeah. My thoughts on protocols as of right now is that they're somewhat scary, and that is more because of tooling than other things. Suddenly, you recompile something and your thing doesn't implement the protocol anymore, and I don't want to be in that situation. But I think then, if you think about how you would do it in spec instead, which is what we're doing. So at the database layer, for example, you would define an entity as something that might have an ID, right? It's a map that has an ID. Whereas at the service level, you would define the spec, which is, or if you had a protocol there, then you would say, oh, what can I do with my user? But the question then arises, why would you want to do that? Because one of the reasons you want to have protocols is you want to swap in a different implementation. So do you really want to swap in a different user service? Probably not. So, yeah.
Cool. I think that's it. Thank you very much, Erik.
Thank you.